Welcome to 4.2, the greedy algorithm. Remember last time when I said I wish that there was a way to make things easier? There is. The basic strategy for the greedy algorithm is to make a list of your colors and a list of your vertices, and usually do that by decreasing order of degree. So see here, this guy has a degree of 1, 2, 3, 4, so I made him number 1. 1, 2, 3, 4, number 2. 3, I made 3. 4, or sorry, a 3 again, I made 4. And then a degree of 2, I made that one number 5. That's the last one I'm going to look at. All right. So the first thing I did was color A, and I colored vertex 1 color A. Vertex B could not be color A, or vertex 2 had to be color B because it could not be color A. Vertex 3 could not be color A or color B, so I made it color C. Vertex 4 could not be A, B, or C, so it was D. Vertex 5 could not be A or B, but it could be C because it's not connected to vertex 3. Therefore, the chromatic number of this graph is 4. And I knew it would be at least 4 because of this click right here, this K4 complete graph that is a subgraph within my larger whole. And that's noted right here. Now, we can use the greedy algorithm and graph coloring to solve word problems. For example, if you're a wedding planner, organizing the rehearsal dinner before the big wedding, you might have 16 people attending the rehearsal dinner, and the bride and groom tell you that A does not get along with F, G, or H. B doesn't get along with C, D, or H, and so on and so forth. Now, it's a little counterintuitive what we'll do here, but we're going to make each person a vertex, and the people who cannot get along, we're actually going to connect. We're going to make them adjacent because that means that those vertices will be different colors. So, vertices that are not connected, that means that they don't hate each other, and we can put them at the same table or color them the same color. Going through here, A does not get along with F or G or H, and so we connected them. And then we were able to color it in such a way that we found that we needed 3 tables. C and F had to be at one of them. D, G, and H had to be at one of them. And A, B, and E had to be at one of them. You can kind of look at that, maybe make one for yourself. And I started with 3 colors because I saw A, G, and F created a click or a K3 complete graph. We're going to do some practice now. All right. So for the greedy algorithm here, I need to label my vertices. So degree 3, 3, 3, 3, 3, 3, 3, 3, 3. All of these are degree 3. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Do I see any complete graphs in here? I don't. So I'm going to start off with A and B, but I'm guessing I'm probably going to end up needing a color C at some point. Not sure. We'll see. I'm going to make color A red. So vertex 1 is red. Vertex 2 does not connect to vertex 1, so it can also be red. Vertex 3 does connect to vertex 1, So it's going to be color B, and I'm going to make color B blue. Vertex 4 does not connect, or it does connect to a red one, so it cannot be A. Let's see. It does not connect to vertex 3, so it can be color B. But then let's look at 5. 5 connects to 3 and 2. So I need a third color. Color C. I'm going to use green. All right. Now, let's move on to vertex 6. It is not connected to color A. Always try color A first. 7 touches color A and color B, so it's going to be color C. 8 touches, oh, no it doesn't. Doesn't touch color A. Color A it is. Now 9 touches color A but not color B. And 10 touches color A and color B, but not color C. So then, according to what I found from my greedy algorithm, the chromatic number of this graph is 3. Okay, let's try this one. Degree 1, degree 2, 3, 1, 1, 3, 4. This is going to be 1, 3. This will be 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. I don't see any clicks, so I'm going to start off with just A and B, and we'll see where we go from there. A is red, so 1 is A. 2 cannot be color A, so I'm going to make blue my color B. So 2 is blue. 3 cannot be A, but it can be color B. 4 can be color A. 5 cannot be A, so it's B. 6 can be A. Remember, anytime it can be A, it's A. 7 cannot be A. B. 8 cannot be A, but it can be B. 9 can be A. 10 can be A. 11 cannot, but it can be B. So then, the chromatic number of this graph, x of g, equals 2. Moving on. All right, I have a K4 complete graph here. So I'm going to have at least 4 colors, A, B, C, and D. Let's see. I want to do my vertices with highest order first. So 1, 2, 3, 4. Those are all the ones with degree 4. Now I'll move to the ones with degree 3, 5, 6, 7, 8, 9, 10, and 11. Okay. Color A is going to be red, and 1 is A. Color B is going to be blue, and so 2 is B. Vertex 3 touches A and B, so we'll make that color C, which is green. Vertex 4 touches A, B, and C, so we're going to make that color D, which is pink. All right, vertex 5 can be color A. Vertex 6 cannot be color A, but it can be color B. Vertex 7 can be color A. It's not already touching a red dot. Vertex 8 cannot be A because it's touching red, but it can be B. All right. Vertex 9 cannot be A or B, but it can be C. Vertex 10 cannot be A, but it can be B. And vertex 11 can be A. So for this graph here, the chromatic number X of G is equal to 4. Let's do the next one. All right, looking for clicks. Now you might think that you have a K5 complete graph here, but you actually don't, because look, J breaks up the line from A to C. F breaks up the line from B to D. There's no direct connection, and so on and so forth. So we do not have a K5 complete graph. Do I see a K4? No. Do I see a K3? All right. Okay. I'm going to start off with A and B. Now I do see here that I have a circuit of odd numbered vertices. So if this is color 1, color 2, color 1, color 2, or color A, B, A, B, this then would be A and B. I would need a third color. So I'm going to put C here because I know I'm going to need it. All right, vertex of highest degree is K. 1, 2, 3, 4, 5, 6, and then we'll do 7, 8, 9, 10, and 11. Let's start off with color A, which is red. 1 is A, 2 does not connect to that, so it will also be color A. 3 does connect, so I'm going to make that color B, which is blue. Vertex 4 cannot be color B, but that's fine because it's color A. Vertex D cannot be color A, but look, it doesn't connect to color B, so it can be color B. Vertex 6 connects to A and B, so that needs to be my third color, C. Okay. Next, let's move to vertex 7. Now, vertex 7 touches A, B, and C. So I'm going to need a new color, D. All right. Vertex 7 is color D. Let's look at 8. 8 connects to color A, color A, color A. So it can be color B. Vertex 9 connects to A and B, but not C. Vertex 10 connects to A, but not B. And vertex 11 connects to A and B, but not C. All right, and that lets us know that the chromatic color or chromatic number of this graph is 4. One more. For this one, we're going to use the word problem here to draw a graph and then use the greedy algorithm to solve. A tropical fish hobbyist had 6 different types of fish: alphas, betas, certas, deltas, epsilas, and thetas, which shall be referred from here on as A, B, C, D, E, and F, respectively. Now, because of predator-prey relationships, water conditions, and size, some fish cannot be kept in the same tank. So we're given a table, and we're shown who cannot be with whom. So we're going to draw a graph to represent the situation. Let the vertices be the fish, and the edges be fish that cannot be in the same tank. So we're going to determine, using graph coloring, the fewest number of tanks needed. All right. So I have fish A, fish B, C, D, E, and F. All right. So A cannot be with B or C. B cannot be with A or C or E. C cannot be with A or B or D or E. D cannot be with C or F. E cannot be with B or C or F. And F cannot be with D or E. Okay, I see a K3 right here, A, B, C, A. So I'm going to need at least 3 colors. All right, if I look, I see that C has my greatest degree, and then B and E, and then A, D, and F are all pretty much the same. So I'll just go 4, 5, and 6. All right, so A is red, and that is 1. 2 cannot be color A, so it's going to be color B, which is blue. 3 cannot be color A or B, so it's going to be color C, which is green. 4 cannot be A, but it can be B. 5 can be A. 6 cannot be A or B, but it can be C. All right, so I'm going to need 3 tanks, and in my first tank, the red tank, I can put C and F. In my next tank, my B tank, I can put B and D. And finally, in my third tank, my green tank, I can put A and E. All right, good job, guys. I will see you next time for 4.3 planar graphs and the 4-color theorem. Have a good one.